All right, we're going to look at some characteristics of quadratic functions. We're going to start off by identifying what the parts of a quadratic function are. So let's start with our vertex. The vertex is the point that is at the lowest part of the graph. So in this case, our vertex is the point -1, -16. So I'm going to put in here -1, -16. So I've already graphed these graphs for you. You're not going to graph these. You're just going to look at the pictures, look at the graphs, and find the parts to those graphs. So that's our vertex. Then we've got a line. There is a line that comes through the middle of our graph through the vertex. Okay, it's a vertical line through the vertex. This line is generally a dotted line. To make it a dotted line. So our line is going to be a dotted line and or a dashed line, and it is the line that shows us the axis of symmetry, or the middle of the graph, where if I took my graph and I folded it in half, I would end up with two pieces that laid exactly on top of each other. So it is kind of the line that my graph mirrors itself across. It's very easy to find. It is a vertical line, so it's an X line. It always goes through the vertex, so it is always whatever the X coordinate of the vertex is, that is my axis of symmetry. It comes immediately down here and becomes my axis of symmetry. All right, we've also got a point here that is my y-intercept. Our y-intercept is the place where the graph crosses the y-axis. So that point is right here at 0, -15. And we can find it also in our equation, when our equation is written this way, which is standard form. We learned standard form when we were doing quadratic formula, but this number right here is my y-intercept. So our y-intercept is the point 0, -15. Okay, it will always start with a 0 and then have a number behind it. All right, our x-intercepts, are the places where the graph crosses the x-axis. Cursor got a little off. So that's here and here at -5, 0 and at 3, 0. So in this case, we have 2. Sometimes we'll have 2. Sometimes we could have 1. And sometimes we could have none. And we'll talk about more about that as we get going. But for now, we're just going to be identifying. So our x-intercepts, sometimes we also call them zeros. Those two words are interchangeable. They mean the same thing. So either one of those works when you're giving it a definition. All right, so then we're going to talk over here on this right side of our equation. So I'm going to get rid of a couple of things real fast. All right, so the next thing we're going to look at is the vertex form. Well, just like the name says, the vertex form already tells us what's going to look like. It's going to have the vertex in it. Well, the vertex are the coordinates right here at h and k. So these two coordinates right down here are our h and k. So that tells us automatically what the vertex numbers are. The only other number we need is a, and a is found, if you'll remember, right here. A is whatever is in front of the x squared. So there's my a. So in this case, I come over here to write our equation. We've got y equals 1 is my a, x minus -1 all squared, and then plus -16. Now, that's not as clean as we could write it, so we're going to rewrite it, make it a little bit better. Y equals, you can leave the 1 in or take the 1 out. Minus a negative is plus 1 all squared, and then minus 16. That gives us a little bit cleaner version of our vertex form. But we didn't have to do any work. All we did was took the vertex and put it in. So our vertex was here at 1, negative 16, and then a was that number in front of x squared. So if we look at this graph, does it have a maximum or a minimum? So remember, a maximum is the top of is a mountaintop, and a minimum is a valley. So do we have a mountain or a valley? I'm going to write that over here. Do we have a mountain or a valley? In this case, we have a valley. So, mountain or valley. I can't spell mountain. All right, and so this case, we have a valley. We have a minimum. So we have a minimum. And our minimum, or the lowest that we go, is negative 16. So the lowest that we go is negative 16. So we have a minimum of negative 16. Domain and range. So domain's going to be easy. It's going to be all real numbers. There is nothing that I can't have for x. It's going to be everything, all real numbers. So from left to right, everything we could possibly want for domain. And then for range, we're going to say we have a minimum, so it's going to be from the bottom to the top. So the lowest we go is negative 16. So we're going to say either y is greater than or equal to negative 16. So y is greater than or equal to negative 16. All right, you can write it that way, or you can write it in the interval notation, which would be negative 16 to infinity. It goes up forever. So either of those is fine. Either one, whichever one you like, is fine. All right, we're going to take a look at our next question. All right, so we're on the orange page now. All right, so again, we've got the graph already listed, so let's go through and find our parts. So we'll start off with our vertex. The vertex is right down here at 2, negative 1. So our vertex is the point 2, negative 1. The axis of symmetry, it's going to be that line that mirrors down the middle. Right, so in this case, it's going to come right through here. That vertical line is always going to be an x line, so it is the line x equals 2. Remember, whatever goes with my vertex also makes up my axis of symmetry. These numbers will always be the same. Then I've got my y-intercept up here on my y-axis. Here's my y-intercept at the point 0, 3. And then we've got our x-intercepts, or our zeros, here at 1 and 3. So at 1, 0 and at 3, 0. Those 2 points for our x-intercepts or our zeros. All right, to write our vertex form, remember vertex form, we're just going to need our vertex. So that's right down here at the bottom, 2, negative 1. And we need our a. In this case, it's a 1. So let's come over here and write it. Y equals 1. And then x minus h. So x minus 2, all squared. And then plus k. In this case, k is a negative 1. So it'll be plus negative 1 or minus 1. All right, this one has a valley, which makes it a minimum. So we have a minimum at the lowest our graph goes is negative 1. So we have a minimum at negative 1. Our domain's not going to change. It's going to be all real numbers. For all of these parabolas, we're going to have all real numbers. And then our range is going to be from the lowest the graph goes to the highest the graph goes. In this case, our graph is everything from -1 all the way up. So we can write it either y is greater than or equal to -1, or you can write the interval notation where we have -1 to infinity. All right, I'm going to go through the next couple a little bit quicker, but again, you can always pause or rewind whenever you need to. All right, so we're going to start here with our vertex. Our vertex this time is right here. So our vertex and our axis of symmetry, remember, are going to match up. So our vertex is up here up top at 3, 4. The axis of symmetry is that line that's going to come straight through that vertical line that cuts our graph in half. It's going to come straight through that axis of symmetry. Straight through that vertex. So our axis of symmetry is always going to be x equals, and then whatever my x coordinate was. So in this case, x is 3. Our y-intercept is going to be the place where the graph crosses the y-axis. So at 0, -5. And then our x-intercepts, or our zeros, are here at 1, 0 and at 5, 0. So at those 2 points, 1, 0 and 5, 0. All right, in this case, we have our vertex form. We're going to come up here and find that vertex form. So we've got a -1 for our A. So in our vertex form, we've got -1. So we'll put y equals -1 times, and then x minus h, so x minus 3, and then plus k, which is our 4. So plus that vertex. All right, so this one has a mountain. Our vertex is at the top of the mountain, so that means we have a maximum. We have a maximum at, and the highest we go is up to 4. So we have a maximum at 4. Our domain is all real numbers, because it's always going to be all real numbers. And then lastly, but not least, is our range. And the range is everything. This time, the lowest we go is to infinity. So it's going to be everything that is, so y has to be less than or equal to 4. Or you can write it with the interval notation where we start with -infinity. And we go all the way up to 4. All right, on to the purple one. So our purple one here, our vertex is here at 3, 0. Our axis of symmetry is going to be that line that cuts down the middle. It goes through the x coordinate, so it is the line x equals 3. Our y-intercept is right up here at 0, 9. Our x-intercepts, or zeros, are the same as the vertex because that's the only place that it touches the x-axis, so it's the same. And we just have one, so you only have to write one of them. So we write 3, 0, just like for the vertex. And then for our vertex form, we're going to come find what's the number in front. That's A. So y equals 1 times x minus 3, all squared. And then we could write plus 0. But do I need that plus 0 on the end? I actually don't, so you don't have to keep that there. This one has a minimum. There's a minimum. And the lowest our graph goes is down to 0. All right, the lowest the graph goes is down here to 0. Our domain is all real numbers. And so our range then will be anything from 0 up. So y will be greater than or equal to 0. Or if you want to write it in the interval notation, it would be from 0 to infinity. Remember, we always have a parenthesis on the infinity side. All right. And one last one. Let's do the pink one. All right, so our vertex is going to be up here up top at 2, 2. The axis of symmetry is going to cut right down through the middle. So right here through the middle. So that would be x equals 2. Our y-intercept is the point where we cross the y-axis. So here at 0, -6. And then last but not least on this side is our x-intercepts here at 1 and 3. We have the point 1, 0. And we have the point 3, 0. All right, vertex form. Vertex form just takes that first number. In this case, it's -2. That's our A. So our vertex form will be y equals -2, or A, times x minus 2, all squared, plus k, which is also a 2. Everything's a 2 this time. This one has a mountaintop, so it's got a maximum. It's going to have a maximum at 2. So a max at 2, our domain is all real numbers. And last but not least is our range. So range is going to be everything from -infinity, or the bottom, all the way up to 2. So y is going to be less than or equal to 2, or we can write it from -infinity up to 2. Either one is correct. All right, and that's it for characteristics.